The following video is going to be about negative exponents. This is a new concept that we've been adding on. I'm going to go through a note sheet here to help you with negative exponents. First thing says, what do you think about 2 to the 4th divided by 2 to the 6th? Now, when we divide powers with like bases, we subtract our exponents. So I should be looking to subtract 2 to the 6th or from 2 to the 4th. So I would get 2 to the negative 2 power. Now, it says if you simplify that problem, where are the 2's? Using the rule, what power is that? So what I'm going to do is I'm going to write out 2 to the 4th power. 2 to the 4th power is 2 times 2 times 2 times 2. And this is divided by 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 6th power. Now, in order to know this, we need to know that whenever a number is divided by itself, like 3 divided by 3, that equals 1. So if I know at least that piece, that should help me with this. So these will cancel out, cancel, cancel, cancel. What I have left on the top is really just a whole bunch of things saying 1 times 1 times 1 times 1, which gives me 1 on the top. On the bottom, these are also 1s. 1 times 1 times 1 times 1, and then 2 2's. That gets me 2 squared on the bottom. So my most correct answer here would be 2 squared. So 2 to the negative 2 also equals 1 over 2 squared. All right? So we're going to simplify some of these here. Another way to think of this strategy is to think of it like it's a battle between the top and bottom portions of this division problem. There's 4 C's on the top and 5 C's on the bottom. Which one has more C's? The top has 4, the bottom has 5, so the bottom has 1 more. So I would have C to the 1st power on the bottom, and that leaves our 1 at the top. We're thinking of it this way. You would be canceling all those C's at the top out. Those are all canceled. It'll be 1, and then the bottom would have 1 left over C. That same strategy here for this one would have 8 X's on the top, 12 X's on the bottom. That would leave you 4 X's on the bottom, and that would leave you 1 at the top. This one here, I've got to first combine them, so my first simplified answer would be x to the 6th power over x to the 10th power. Now if I wrote all those out, that would get me 6 on the top, 10 on the bottom, and I would have 4 extra x's on the bottom. So I get x to the 4th, and when I canceled all those out, I'd have 1 on the top. Now for this last one here, I'm going to go down a little bit to do the last one here, there's multiple things. So if I get a to the 3rd and a to the 5th on the bottom, there's 2 more a's. So I could have a to the 5th on the bottom if those were canceling out. At the top there, you have b squared, b to the 7th. That makes b to the 9th on top, and this has b to the 10th on the bottom. That means there's 1 more b that would be on the bottom, and the whole top would cancel out to just be 1's. Now, some of the other options. For this one, if you initially had c to the negative 1 power, that is okay, but not our most simplified answer. To simplify that completely, we need to make it go we need to go under a 1, then it makes it positive. We'll talk more about that rule here in a second. Okay, so what do you think the rule is? I broke it up into a couple of different rules. Okay, here's the first rule. The first rule is a variable or number raised to any negative power equals 1 over that whatever variable or number is to the positive power. So same number, just this one's negative, this one's positive. That's our first rule. The second piece of this rule is 1 over any variable or number to a negative power equals that variable or number to now the positive power over 1. So here we are flipping top and bottom. This one's a negative, This one's a positive. Here we flipped. This is really like a ninja one that's underneath this one. It's really like a ninja one there underneath it. And it switches and turns positive and negative. Now for another example, this can be any number or variable to a negative power over any other, maybe a different variable or number to a different negative power. That equals them flipped, so that would be a to the positive b power over x to the positive n power. Whenever they flip over the division bar, they turn positive. All right, and the last piece I'm going to type in here, we say no negative exponents in final simplified form. I need to shrink that a little bit there. No negative exponents in final simplified form. All right, so those are my rules. It says that negative exponents are not necessarily negative numbers. Okay, what we mean by that is if we do 2 to the negative 3 power, if I take this example, that would equal 1 over 2 to the positive 3 power. Now, how can we prove that? Well, 2 to the third power means 2 times 2 times 2. Okay, 2 times 2 is 4, 4 times 2 is 8. So that equals 8. Well, 2 to the negative third power should equal 1 divided by 2 to the third power. So 2 to the negative third power, this should be 1 divided by 8. So let's see, 1 divided by 8. That gets me 0.125. So that gets me 0.125. Now if I do 2, I got to figure out how to do my exponent on this. I'm going to go to Desmos real quick. If I do, here I've got 2 to the negative third power and 1 to the 8th, or 1 divided by 8. I still get the same value for each of those. It's important that we understand that these negative exponents aren't negative numbers. All right, so here's some ones to practice. You can pause the videos and practice these couple ones, and I'll put the answers in. All right, let's see how you did. 2 to the 5th divided by 2 to the 7th. That gets me 2 extra 2's on the bottom. So I'd write 2 squared on the bottom and leave a 1 at the top. In number 2 here, we've got 3 to the third power over 3 to the 5th power. The bottom one has more, so this would reduce to be 1 over 3 to the second power because it has 2 more. Number 3 here, it's got c to the 12th times c. They get c to the 13th on the top. On the bottom is c to the 15th. There's 2 more on the bottom, so that turns to be 1 over c to the second power on the bottom. This last one has x's on the top and on the bottom. The bottom has 2 more x's, so on the bottom I would write x squared. The y has nothing on the bottom, only on the top, so I would have y to the 6th. And then the z's have more on the bottom. They have 2 more on the bottom than on the top. I've got some more practice ones for you to try. Try these ones. These have to do with multiplying powers with like bases. Okay, if you tried these, here is how you would do this. Based upon our rules, this equals 1 over x to the positive 4 power. Here I would multiply the powers with like bases and add their exponents. 6 plus negative 4 gets me 2. It's positive 2, so this is just x squared. This next part, x to the negative 6th power times x to the negative 4th power, That gets to x to the negative 10th power, but that's not my most simplified answer. I can't have x's as negatives. So what I got to do is I've got to change that, and the answer to this one is 1 over x to the positive 10. For 8, my a's, I get a to the 9th with 3 plus 6. And then b is negative 2 plus negative 4. That gets me b to the negative 6. But that's not the most simplified version. What I've got to do is, since this is a negative power, is I got to put it underneath a 1. When I do that, that leaves me a to the 9th as a positive on the top. And that moves b to the 6th, now it's positive, to the bottom. So if one's positive, one's negative, they're being multiplied, the one that's negative needs to move to the bottom in order to make it positive. That's the final answer to 8. Here's a couple more ones to try. Pause the video and try to solve these problems. Number 9, the rule would be c to the 15th power over 1. It flips since it's a negative on the bottom. Once it goes up to the top, it flips. Here there's a negative on the top and a negative on the bottom. In order to make them both positive, we just flip both of the fractions. That gets you b to the 1st over a to the 12th, and they become positive once you flip them. We've got a to the negative 4, y to the 2nd, over x to the 4th power. Now there's a couple ways you can think about this one. One is, which has more top or bottom and by how many? There's more x's on the bottom by 8. Or you can do the original dividing powers with like bases. You subtract their exponents. Negative 4 minus 4 gets you negative 8. So that would be x to the negative 8 power, y to the 2nd power. Now this is just like the one we did back here, where when they were side by side, the negative exponent had to go down. So my best final answer for number 11 would be y squared over x to the 8th power. For number 12, here I've got c to the 12th, b to the negative 8th, c to the negative 15th. 12 minus negative 15 gets me c to the 27th power. And then I've got b to the negative 8th power. Now I can't have b to the negative 8th, so that one's got to go underneath. My final answer for number 12 is b to the 27th over, sorry, c to the 27th over b to the 8th power. That's my final answer here for number 12. Use this video to help you with answering questions to negative exponents and to keep you sharp.